no ethanic acid.
Ethanoic acid. What haven't you understood? Because I need to know where exactly so that I can know what to talk about so that we can move to something else. Please, learner, the indicator is neither acidic or alkaline. That is why we are using it to test for those substances, whether they are alkaline or acidic.
Madam, she was saying why the arrows I have. This one facing this side and this one facing this side.
Can you tell her why?
Can you?
Even I can't because I wasn't around.
Let's go back and watch those videos. They will help you. Yes,
Okay.
Eunice.
Thank you.
Sister,
Welcome.
I would like to re-explain for that person who has not understood.
Please do.
Okay. I think where she might have not understood is the reason to why there are two H's in the what? In the short form of ethanic acid. But the reason is hydrogen and ethanoate. All of them contain hydrogen ions. So when you dissolve all of them in water, only the hydrogen ions in hydrogen will turn positive and the hydrogen ions in ethanoate will remain negative.
Thanks.
Okay, thank you. So just to wrap up what she has said, I said when you look at this ethanoic acid formula, you realize that we have three hydrogens here, and then we have one hydrogen here, which makes them four hydrogens. But when you come this side, this last hydrogen here, this last hydrogen here is what forms the hydrogen ions. But these three hydrogen ions have remained within the what? The structure that is negatively charged. So in that case, you realize that this one becomes a weak acid because not all the hydrogen ions become positively charged. I hope that is more clearer now.
Yes.
John, the notes are always sent, but you need to also take down notes as the teacher is explaining. Because remember, in class, we are expected to teach and then you make notes as we guide you. And I think these notes are good enough to guide your note making. Eh? So we are not old curriculum where I send notes and you copy from what I've sent. Eh? So let's learn to make our own notes depending on what we are covering, surely. So that my notes, by the time I send them, you're just looking through to organize your notes, not to copy from them. Okay, so let's proceed. So like here, I have some few examples of strong acids and strong and weak acids. So we have hydrochloric acid, sulfuric acid, nitric acid. So in this case, like I have explained, we have hydrochloric acid being a strong acid. That means it's going to dissolve in water to give us hydrogen ions as the only positively charged plus chloride ions as the negative ions. So that is how that's how hydrochloric acid is. Then for sulfuric acid, since it's a strong acid also, we'll have hydrogen ions plus the sulfate ions. Isaac, maybe please you can reshare the WhatsApp group link so that those who are not there can join and they can have access to the video and rewatch it. Then for nitric acid, we said it is also a strong acid. That means we'll have nitric acid giving us hydrogen ions as the only positively charged ions plus the nitrate ions. So basically, these three are the common ones that we look at as the strong acids. Okay, so then when we go to the weak acids, I'm just writing for us these equations just to clear out the air on why we call them weak and why we call the others strong. So for the weak acids, we have ethanoic acid, which we've just written the other side, but I can repeat it here. So we have the double arrows, meaning it's a reversible reaction. Then we have hydrogen ions plus the ethanoate ions. And then for methanoic acid, we also have something of this sort. So since methanoic acid is also a weak acid, we'll have hydrogen ions plus the methanoate ions. So still here, you realize we've left a hydrogen on the negative part, so that is why it becomes a weak acid. Then for carbonic acid, we have this. So since it is also a weak acid, it will have reversible arrows plus hydrogen ions to give us hydrogen carbonate ions. So basically, that is what differentiates the weak acids from the strong acids. Strong acids, all the hydrogens are produced as positive charges, while this side, you have a hydrogen remaining at all costs. So you can see this hydrogen here. There are 3 hydrogens here. Here there is 1 hydrogen, there is 1 hydrogen here. So not all the hydrogens are forming a positive what? Hydrogen. Can we move? Are we all together up to that point? Thank you, Isaac, for reposting the link.
Yes, madam.
Okay, thank you. Nora's hand is up.
Madam, I was asking that you said that because they are weak acids, we use this type of arrows, the half arrows. So does that mean that when we are working with strong acids, we don't use those types of arrows?
Yes, I've just written the strong acids, and you would realize that all of them, the arrow was full. Is that clear?
Yes, madam.
Okay, so let's move to something else. Okay, so we have so we also have this other one when we come to alkalis. So we say the degree of alkalinity in sodium hydroxide is much higher than that in baking soda solution. So baking solution you can test, because remember, at least most of you that bake at home, you use the baking soda. So that means for it, you can test and know that it is bitter. But when it comes to the sodium hydroxide, we don't expect to find you testing the sodium hydroxide in the lab, because you want to know if it's an alkali or an acid. So we also have weak and strong alkalis in this case. But in the lab, we have very many hydroxides, but the common weak alkali that we always consider is ammonium hydroxide. So in that case, when we have sodium hydroxide, the same thing is happening here. When we have sodium hydroxide, there is a blue background and I'm using blue. I hope people are able to see what I am writing. So we have sodium.
Yes, we are.
Okay, thank you. We have sodium ions plus the hydroxide ions. So in this case, you realize that I have a full arrow because in this case, you realize that all the hydrogens that are combined with the hydroxide are going with the hydroxide, the other side. Then for potassium hydroxide, still the same thing is happening. I have potassium ions plus hydroxide ions. That's why you say for alkalis, they dissolve in water to produce hydroxide ions as the only negatively charged ions. Thank you, Isaac, for sharing the YouTube channel link. So those ones who didn't watch the previous lesson, you can copy that link and watch it later. So after that, we can look at ammonium hydroxide. So I'm going to leave this equation here so that you can help me compare with the one for hydrogen hydroxide, for ammonium hydroxide, and you tell me the difference. So here we have ammonium hydroxide to give us ammonium ions plus the hydroxide ions. Who can tell us why they think we've used double arrows here, yet here we have a single arrow? Who can tell us what they think? Yes, Laura?
I think maybe the solution is reversible.
Okay, thank you. Mary?
Because we have reversible hydrogen ions.
Okay, Tracy?
I think the same. I think we are both the same. We both have the same answer.
We are both there.
Thank you. So I said when we are dealing with weak acids or weak alkalis, we use these reversible arrows because some of the hydrogen ions remain within the other part of the compound. So that means this reaction can be reversible. So you realize that here we have the hydrogens which would have gone with the hydroxide also remaining as positively charged. So therefore, it has to obtain those double arrows. Then when you come to potassium hydroxide, you notice that there is no hydrogen here on the K. So all the hydrogens went with the hydroxide part. So that is why we use full arrows here and double arrows here. Are we on the same page up to that point?
Yes.
Okay, good. So those that we might have left behind or you seem lost, please make sure you get found when you watch the YouTube video. Don't allow to go back to school not knowing what we have covered today. Okay, so I was still saying those of us who didn't understand, you might need to as well. Even though you've understood, you might need to go back and watch the video so that you can check yourself. So for the strong alkalis, you can list more examples. At least I gave you two. Can I hear from some of us some more examples of strong alkalis before we move to the next? Yes, Martha?
Calcium hydroxide.
Hmm?
Calcium hydroxide.
Okay, calcium hydroxide, thank you. Okay, so we have a question here. What is pH? Who can tell us what they think about that question? Yes, Martha. Grace? Okay, let's hear from Austin.
Amanda, I think pH is a degree of acidity or alkalinity of a substance.
Okay, thank you. That is good. Martha, you have a different suggestion? Do you have a different suggestion, Martha? You're already unmuted, I don't know.
Yes.
Mm-hmm.
Oh, sorry, I thought it was pH scale.
Okay, let's hear from Lara.
pH is a measure of a solution's acidity or alkalinity.
Okay, thank you. That is good. Nora? Okay, let's hear from Charles.
pH is a figure expressing the acidity or alkalinity of a solution.
Okay, thank you. Jerry?
pH finding measure of the acidic solution.
I need to hear the first words.
pH is an indicator of a solution of acidic substances.
Okay, thank you. Melissa?
Is the concentration of hydrogen ions in a solution.
Okay, thank you. Austin?
pH is a scale used to measure the acidity of aqueous solution.
Okay, thank you,
pH. pH is a figure expressing the acidity or alkalinity of a solution.
Okay, thank you. Edina?
pH is a measure of the acidity or alkalinity of a solution equal to the measure of the salinity of a solution equal to the common logarithm of the reciprocal of the concentration of hydrogen ions in moles per cubic decimeter of a solution.
Okay, thank you. I can see most of us are making use of Mr. Google. Thank you, all of you, for your contributions.
Thank you, all of you, for your contributions.
Welcome, madam.
Okay, so as most of you have said, that is the degree of alkalinity or acidity of a solution. And the pH in full, like you can see how I wrote it here. pH has small p and then capital H. So never get yourself writing pH like that. You'll be on your own if you write pH like this or like this. This is wrong and this is wrong. This is the correct thing. So please adjust for those of us who haven't adjusted. And in full, we can define pH as potential hydrogen. That's why someone mentioned about the degree of hydrogen. So in full, we can call it potential hydrogen. P for potential, H for hydrogen. Yes, Edna. Okay, so let's continue. So who can tell us how we can determine the pH of a substance? Isaac, I don't know if you got a stable network and a more quiet place.
Yes.
Go ahead.
I think one can determine the pH of a substance by using an indicator.
Okay, thank you. That is good. Any other contributions? Three, using a pH meter, very good. Now someone is saying pH in full is potential hydrogen. There is no of, it's potential hydrogen, period. So don't include the of. Yes, Martha?
We can use the pH scale.
pH scale, okay, thank you. So we can use the pH scale, pH meter, or we can even use the universal indicator. Remember when we're looking at indicators, we looked at litmus paper, methyl orange, and phenolphthalein. Those can only tell us if we are looking at an acid or an alkali, but they can't tell us the pH of a what? Of a substance. So in this case, we can use a universal indicator and a pH scale where you can have the pH meter to determine what the level of pH that given substance has. Okay, so I want to illustrate for us something here. Let me see. Just a minute. Okay, so I wanted to get a diagram on the what? On the pH scale.
Yes.
So I want to share it with us. Okay, so there are different pH meters that you can use here. I hope all of us can see my screen.
Yes.
So
Yes.
when you have your substance, you can just insert, like for example, this yellow pH meter. You can just place the meter into that solution and then it will give you the digit in which that pH reads. And looking at that digit, of course, like we are going to look at the pH scale, you can see some of the colors here, much as the letters might be a bit small, but at least you can see the different colors that it is able to give you. So for example, when you are looking at a pH scale, we have it running from which numbers to which numbers. Which numbers does the pH scale run from?
From
Yes.
0 to 14.
From 0 to 14. Okay, thank you, Ezra. But please, next time, raise your hand.
Okay.
Thank you. So that you don't cheat people who have raised their hands. So it runs from 0 to 14. So we know that at 7, that is a neutral pH. That means below 7, that becomes the acidic pH. Then above 7, from 8 to 14, that is the alkaline pH. So for example, this one here is reading 5.78. That means this substance here falls under the acidic solutions because from 0 to 6, that is the acidic scale. Then 7 is neutral. Then from 8 to 14, we have the alkaline scale. Austin, that is the standard value of reading of those pH. Then there is also another pH meter here where you have the substance and the spring-like thing is inserted into your substance, like you can see here, and then it's able to read off what pH you have. The same thing with this one here, it's a digital kind of pH meter. This one is analog because it's reading numbers. It's not showing the digits as is. Then you also have one here, and they go on and on and on. You can as well find out more from Mr. Google after the lesson. Then I had also talked about the pH scale, which I want us to look at. And please screenshot this pH scale or note down, because I'm going to ask you for the different colors and what pH that is. For example, this one is really coming out very well and it's showing us those different colors. So let's look at them very well and note down which colors are in the acidic component and which ones are in the alkaline component. For example, this one is even naming those colors: red, pink, orange, beige, yellow, lime green, green, dark green, turquoise, pale blue, blue, dark blue, violet, and then purple. So we have very acidic at red, at pink, and then of course there is slight acidic at lime green and yellow, and then neutral is green, then slightly alkaline is dark green, turquoise, and then very alkaline, we have purple, violet, dark blue. So like we'll see, acidity, the lesser the value, the higher the acidity. For example, when you have acidity as 1, 2, and 3, that one is a strong acid. But between 4, 5, and 6, that one is a weak acid. Then when you come to the alkalines, the higher the value, the more alkaline it is. For example, 8, 9, and 10 are weak alkalis, while 11, 12, 13, and 14 are strong alkalis. The person yawning, you should mind muting your mic next time. No, it's not possible to go beyond 14. It stops at 14. That is the scale. For example, when you have a scale that I am running from this to that, it is a standard scale. But of course, we would love to have more Ugandans discovering chemical terms. You can discover for us a scale that exceeds 14 and you give us the theories on why you think it should exceed. And we can back you up if you have the evidence that it can exceed 14. Tanya, can you please stop writing on the screen? Okay, otherwise, and to give us a 5-minute break. So please at 3:38, our lesson will proceed. So just go stretch your hands, stretch your legs, drink some water, ease yourself, and then come back. So you can as well take a screenshot of this so that when we come back with the slides that I'm about to show, we can just be in sync together. So you can note down in those 5 minutes, you can use 3 for noting down. Yes, you can. The person that has inboxed me the message about blood, you can. Please, those asking when we are stopping, they sent you the calendar, so please go back and look at it and use it. What's the difference between people's blood and animal blood? I presume they are the same blood. That's why they are all called animals. I don't think there is a difference with. Those people writing on our screen, stretch your legs and stop wasting time.
They have bad manners.
Drusilla, I don't think you would survive if you had alkaline blood or acidic blood. So really, your blood has to be neutral. That's why your skin is able to contain the blood. Otherwise, if it is any of the other two, you may not be the same. Eh?
Excuse me, madam.
Please.
I have a question. I wanted to ask, are you going to share the presentation into the WhatsApp chat?
Yeah, even the other time Mr. Kazuba shared it. But like I said, be noting down, you're not going to copy exactly what I have. My notes are just to help you compare with what you wrote.
Yes, ma'am.
Yes, because even why I hesitate to send is because people will just Xerox my whole presentation instead of using it to just put a few things where they missed those things. Please, those who are still writing on my screen, I told you go and take water. Don't write on my screen if you're idle. Once writing, stop being a baby, stop writing on my screen. You can ask for the number of whoever you're telling, and then maybe you can text yourselves later after my lesson. Because if you misuse the rights of us leaving you to be able to write on the screen, will restrict you like I'm doing with the chat, because most of us don't know how to behave socially. So we need to always force you to behave according to the way you're supposed to behave, which is not good. Eh? Just learn to behave well, especially when you're among people.
Yes, madam.
Very, very important.
It's time.
Okay, thank you. Okay, so I am sure all of us have now taken note of the colors. So on my next slide, you're going to just tell me which pH that given substance has. Okay, so here we go. Dilute hydrochloric acid, which is a red color, which pH does it have? Yes, Elvis?
It's very acidic.
Okay, what is the corresponding pH? What is its pH number, pH value? It's very acidic, but which pH value does it have? Because we looked at, I told you to screenshot the colors. Yeah, 7, are you for real? 7 is a neutral color, and then you're hearing acid, and then you say, 7, Eunice?
I made a mistake. It's 14.
An acid? Okay, let's hear from Kakai.
Dilute hydrochloric acid, the color is red. And it's a very strong acid, and its same number is 1 to 2.
Okay, very good. So we can consider the pH there, the pH numero to be 1 or 2. Ezra, you're doing a good job, but I want people to contribute before you write on my screen. So maybe if you would write after people have contributed, that would make sense. Okay, sodium hydroxide, which is purple, which pH value does it have? Teyune?
14.
14, very good. Some others can also post in the chat their answers. Then we have lemon juice, which is yellow. What is the corresponding pH? The color is yellow. What is the numerical value? Yes, Charles?
5.
5, okay, very good. I can see the chat. People are also sending in 5, good. Then we go to diluted soap. It's blue. Which pH value does it hold? Nora?
11.
11. Okay, I can see people in the chat are also texting in. Thank you. Then we have soda ash solution. It's blue still. It should hold the same pH value. Then diluted bleach. It's blue. What is its pH value? Diluted bleach. Let's hear from Lara.
14.
14, good. Then distilled water. Let's hear from Liz.
2.
Green is
7.
7, very good. So it's neutral. Thank you all for your contributions in the chat. Okay, so when the slides are sent in, you can as well write for yourself the corresponding pH values. And of course, we can notice which ones are acids in this table. Which ones are acids in this table? Someone just tell us. Which ones are acidic? Sorry.
Acid.
Okay, good. Another one.
Lemon juice.
Lemon juice, good. Another one. I think that's all. Thank you. Then the ones that are alkaline.
Distilled water.
No.
Diluted bleach.
Diluted bleach, good.
Distilled soap.
Distilled soap, good. Sorry, diluted soap, not distilled soap.
Sodium hydroxide.
Sodium hydroxide. And then soda ash solution. Then this distilled water is what? Is neutral. That's why it has a pH of 7. So we need to take note of those things by now. Edna, your hand is up. Faith?
Nothing, madam.
Okay, so we can move on. So we have some discussion questions here. What is the range of the pH values of acids? You can post in the chat or you tell us, you raise your hand and tell us.
Excuse me, madam.
Zero.
Yes, please.
Excuse me, madam. I can take over. The range of pH value of acids, I think, is 1 to 6.
Okay, very good. 1 to 6, thank you.
You're welcome.
Then we have our next question here. What is the range of pH values of bases? Semakula? Okay, we have 8 to 14 in the chat. Thank you. We have a next question here. Someone to unmute and tell us the answer to that question.
7.
7.
7, very good. So like we say, pH can also be measured directly using a pH meter. So are we all good up to that point?
Yes, madam.
Okay, thank you. So we have here reactions between acids and alkalis. So we've looked at pH, we've looked at indicators, we've looked at what an acid is, what an alkali is, but now we need to know when they are reacted together, what happens.
Yes.
Anyone to read for us this statement?
An acid reacts with the base to produce salt and water only.
Okay, very good. And I remember I hinted on that when I was explaining what a base is. So an acid is going to react with a base to produce a salt and water only. So this reaction between an acid and the reaction between an acid and an alkali is a neutralization reaction. Something maybe I need us to understand before we move further is when we are looking at acids, alkalis, and then bases. So there is a statement I want us to always recall and have it at the back of our mind. When you're looking at alkalis, all alkalis are bases, but not all bases are alkalis. So I need you to take note of that. All alkalis are bases, but not all bases are alkalis. So what do I mean by this? Remember we said alkalis are substances which when dissolved in water produce hydrogen ions as the only negatively charged what? Ions. But when it comes to the base, a base is a metal hydroxide or oxide which reacts with an acid to give you salt and water only. So in this case, we have, as we go about the reactions, we'll see some of those few things and we will be able to relate on what I'm talking about. Okay, so I don't know why there are some grievances in the chat. If you have a question, please bring it forth because I'm going to wrap up these statements and we'll move on. Okay, everyone is good. Okay. So in that case, we have, for example, everything that has a hydroxide qualifies to be a base and it qualifies to be an alkali. But when you look at other bases, I can look at sodium carbonate, I can look at sodium oxide, potassium oxide, all those fall under bases. Yet when I'm talking about hydroxide, it falls under bases and alkalis. So that is something you need to take note of as well. So, can I have someone to answer this question for us, either in the chat or you put up your hand and you tell us, how can too much acid in the stomach be reduced? Because sometimes people are saying, oh, my stomach, I don't know what is happening. It's hurting, it's that, it's the other. Yes, Isaac?
Yes, I think, according to me, I'm not sure of the answer, but according to me, since we saw here that acids react with the base to produce salt and water. So this, I think the solution is to drink water and then the acid will be reduced. I'm not sure of that.
Okay, thank you. What substances are in water that are going to reduce the acid? Because if you're to take water, it should have something that will reduce the acid, right? Okay, so I'm seeing some people here telling me drink water, taking less diluted alkali. I think taking milk, okay. So, like we said here, we have a reaction between an acid and a base to produce salt and water only. So in this case, something should click in your mind that to reduce the acid in the stomach, you should take something that contains a base kind of thing, so that it produces the salt and water that can be used by your body eventually at the end of the day. So let me get someone to read for us this statement that is here on the screen. Yes, Hannah.
Dilute hydrochloric acid in our stomach provides a medium for digestion of food. However, the stomach secretes excess acid. It causes indigestion. The acid burns the lining of the stomach, hence causing peptic ulcers. Alkaline substances neutralize the excess acidity in the stomach.
Okay, that is very good. So, first of all, you have to understand that in our stomachs, we have dilute hydrochloric acid. People who don't eat well or who eat in a disorganized way usually experience ulcers as a result of the hydrochloric acid. Because much as it's important because it's helpful in the digestion of food in the stomach, but also you have to understand that your stomach in most cases releases excess acid, which causes that most people experience heartburn and they start saying they have heartburn. So these are some of the instances. The acid in your stomach increases or is excreted at a higher level, and you realize that it starts to burn the walls of your stomach, causing you peptic ulcers. So in this case, we have to get something that can neutralize the acid. And we have said the reaction between an acid and an alkali is called neutralization reaction, because at the end of the day, you're producing water, which has a neutral what? A neutral pH. And the salt also has a neutral pH, depending on what substances you have used in the acid and the alkaline. So in this case, we have substances that we can use. So we can use antacids like milk, sodium bicarbonate, which is baking soda, like I've seen in the chart, and magnesium hydroxide. That's why most people, when they go to the hospital, they are given magnesium syrup or magnesium tablets to calm down the intensity of their peptic ulcers. So you realize that it is able to neutralize because the reaction between the acid and the anti-acid is able to create a neutral kind of atmosphere in your body. And they are used to relieve heartburn and indigestion, or to make blood and urine less acidic because they are alkaline in nature. So it's important for you to have those at the back of your mind. Hey, the person saying they need lemon juice. Have you ever seen a doctor prescribing people with peptic ulcers to take lemons or pineapples? So it's important that you, the future doctors, even though you're not a doctor in the hospital, you can be a doctor taking care of someone at home. So don't risk to give them things that are very acidic, yet they are trying to overcome the acidity nature that is within them. So let's be very good doctors even at home. I'm sure everyone that is doing chemistry can be a doctor, really. Not a medical one, but someone that can always help. Yes, Austin.
Madam, I have a question.
Yes.
What are the examples of components in milk? Like something like that, apart from lactic acid.
Please find out and tell us, because we would love to hear what you think or what you found out.
Yes, madam.
Nora has a question here. Are bananas or matoke acidic? Someone can respond to that as she also finds out what components are in matoke that cause doctors to tell people to stop eating them. Okay, so maybe as we find solutions to those, there is also something here. Most people, when they are stung by bees, they run to the hospital very fast, crying that they have lost their body parts because of bees. So here comes a solution. At least you can give the person first aid, then you take them to the hospital afterwards. So can I get someone to read it for us? Yes, Isaac, you overread. Please let someone who hasn't said anything at least read for us. At least the answer is here. So just read for us. Melissa? Isaac in good heart. Let's give other opportunity. Yes, Melissa.
Today's lesson is wow.
Me, madam.
You read for us. Isaac, please read for us. Will he disappear eventually?
Me? Okay.
Read for us, because we need to conclude. That time is fast spent.
Okay, teacher. These things are acidic and can be neutralized by rubbing a solution of banana peelings or baking soda on the site which the bee stung.
Okay, very good. Thank you. So when you're stung by a bee because of the acidity of the acidic nature in the sting, you can neutralize it by passing a banana peeling or by using baking soda so that you can neutralize the acidity in the sting. So those are some of the things you need to go back and find out. I'm seeing a lot of questions in the chat. So please find out. You can even share in the WhatsApp group what your findings were on those questions. Then the other thing, this presentation will be posted in the group, because I think today, most likely, if we are not able to have our lesson next week, we can always refer. And then can we have someone to lead us in a closing prayer, and then we can call it a day?
Yes.
Shamia.
Pray.
Let's humble our souls. King of glory, thank you.
Please, let's mute our mics and the person praying praise.
Bismillahirrahmanirrahim.
Okay, have a blessed day, and thank you for connecting for the lesson.